Okay, so welcome everyone. My name is Anne Kirk and I'm a director on the Manitoba Organic Alliance board and the cereal crop specialist with Manitoba Agriculture. This last season, Manitoba Organic Alliance conducted their first on-farm field trials, and we're going to give an overview of the trials and findings today. So joining me right now are Glenn Elliott and Alan McKenzie, two of the farmers that participated in the on-farm trial. So I'll be giving a brief overview of the trials and the findings, and then asking some questions, and Glenn and Alan will be sharing some of their experiences. And we may be having an additional portion of the presentation. Great, so I'll just start by giving a description of on-farm trials in general. So the first question would be, why do we do on-farm trials? There's lots of research done with the university and other research institutions, but on-farm trials provide a different dynamic. We have some unbiased, accurate data collection. So we use scientific practices to ensure the results are true and reliable. So for on-farm trials, treatments are replicated 3 or 4 times across the field. So this allows us to make sure that an observed difference is consistent across the field. So side-by-side comparisons can be misleading due to differences in environment. So sometimes we do see people, comparing, say, 2 varieties, one planted on 40 acres, the other planted on the other 40 acres in a field. And any differences that we see in yields between those varieties due to, differences in weed competition, soil nutrients, environmental or soil type, it's hard to know if those differences are representative of the varieties themselves or just where they were planted in the field. So on-farm research provides a benefit to the farmers that participate because they can see how a variety or practice performs on their own farm. And they know that the research results apply to their environment or soil type. And the more on-farm trials we do, the better, the more data we collect and the more geographical representation we have across the province. And other farmers can, use that data to help make management practices on their own farms. So both small plot and on-farm research have their place. Often on-farm research trials kind of come after some of the small plot research. So small plot research allows for comparisons between a large range of treatments that might not be practical at a field scale. So for example, if we're comparing, a small plot research might compare 20 different varieties. An on-farm trial, we might be looking at the 4 best varieties or the 4 varieties that might be, most representative of what farmers want to grow. So just a list here of how to conduct on-farm trials. So the first step is to form a research question. So for example, that could be, I usually seed my wheat with a target plant stand of 300 plants per meter squared. Would I gain any yield going up 50 plants per meter squared, or would I lose any yield going down 50 plants per meter squared? And then select treatments. So whether that's, your seeding rate treatments. The next step is the trial layout. So I have an example of trial layout on the right-hand side of the screen here. So replicate multiple strips of the same treatment to minimize variability. So 1 replicate, and you can see here on the screen I have rep 1, 2, 3, and 4. 1 replicate is comprised of 1 set of treatments. So in this example, each treatment is replicated 4 times in 4 different strips across the field. We also randomize the order of treatments within each replicate, which helps to avoid patterns of treatments across the trial area, which helps to prevent bias. The trial is established either at seeding time or after seeding, depending on the nature of the trial. Relevant data is collected, and then the data is analyzed. So the statistical analysis is important to determine the outcome of the trial. So yields will naturally vary across the field, and statistical analysis is the only way to determine if numerical differences in yield between treatments are the result of field variability or from the treatments themselves. If there's no statistical significance across treatments, then the numerical differences are considered to be a result of random variation. So for this trial, we conducted an on-farm wheat variety trial this year with the objective of quantifying the impact of variety on yield and baking characteristics of spring wheat grown under certified organic management. So we are interested in looking at the yield and agronomic characteristics of a range of varieties, since there's limited information on variety performance under organic growing conditions. Breeding, registration trial, and post-registration assessments typically take place under conventional growing conditions, which allows for limited comparisons on organic farms. So in order for farmers to make informed decisions when choosing varieties, we need to know how they perform under typical organic growing conditions. So for this trial, we established trials at 3 certified organic farms in Manitoba, and the treatments were 5 Canadian Western Red Spring wheat varieties. So I have the variety names up on the screen, and these varieties were chosen in consultation with the cooperating farmers, the project funder, and agronomists. The plot size varied depending on the size of seeding and harvest equipment, but was about 2.5 acres per plot. So each strip on the right-hand side of the screen is 1 plot. So in order to get a pure harvest pass with a combine, in most cases, a plot was two cedar widths. In one farm, it was 3 cedar widths, and then went down about the length of the field. And the trial areas were prepared using the farmer's typical management practices and maintained throughout the growing season using the typical management practices. So just have a list of the variety characteristics here, and this is from Seed Manitoba, which is the publication that we put out every year with variety information. So I just wanted to bring this up. The yield and protein data is collected from our conventional post-registration McVet trials, and the agronomics, so the maturity, height, and disease resistance data, that's collected at the time of variety registration. So I think that the agronomic and disease resistance data is very, very relevant for organic farmers when trying to decide on varieties. The yield data is collected in conventional small plot trials, so may not be that relevant. I just wanted to give an example here of the 5 varieties that we chose and how they performed in the post-registration variety trials under conventional management. And I just bring this up because there actually wasn't a lot of difference in the yield between these 5 varieties over about 35 site years of testing in the McVet trials. So the same letter above, if bars that contain the same letters are not considered statistically different. So for example, Brandon, Redberry, and Starbuck all contain the letter A above their bars. Therefore, we consider these yields not significantly different. Whereas Starbuck, Tisdale, and Cardale are considered to yield significantly lower than Starbuck. But the Brandon, Redberry, Tisdale, and Cardale all yield about the same. So we wanted to see if these sort of results are relevant for the organic farms and if we'd see any significant differences in the varieties. The disease resistance data is up on the screen from Seed Manitoba as well. This information is all collected from inoculated small trials from disease nurseries, mostly done in Agriculture and Agri-Food Canada, prior to the time that varieties are registered. So since no fungicides are applied and they're inoculated, this data provides good information on how those varieties will perform when in contact with those diseases. So for seeding, at seeding time, the boundaries of each strip were flagged, as you can see on the left-hand picture. We're flagged with extra flags at the 4 corners of the field and GPSed. So since we were looking at 5 different varieties, 5 mini bulk bags were delivered to each farm. Cedar was cleaned out, seed was added, and then all seed of that strip. So for example, if AAC berry is being added to the cedar, all of the AAC berry plots were seeded, the cedar was cleaned out again, and then the next variety was seeded. So definitely, takes a bit extra time at seeding to set this up. Okay, and the data that we collected during the growing season, we collected plant stand, vigor, disease ratings, height, lodging, and yield. I'm just going to be discussing height and yield. There was very little disease since it was so dry. No differences in early season vigor or lodging between the treatments. So for the weather and site characteristics, I have the soil type of the 3 sites listed on this graph, as well as the precipitation and growing degree days. So I think it's important just to consider, I think it's great that we were looking at 3 different soil types in this trial. So from a clayier soil, a loamier soil, and then a sandier soil. And all 3 locations experienced lower than normal precipitation throughout the growing season and higher than normal temperatures. So in July, most of the prairies were extremely dry, and all 3 of these sites received less than 50% of the normal precipitation in July, which is, a time where the wheat plants are going through a lot of growth and development and really need that moisture. At site 3, which was the sandiest soil, so there's 65% of normal precipitation in June and 11% of normal precipitation in July. So this resulted in poor plant growth throughout the growing season. So the plant height results, we do have, large differences in plant height between locations, and this was a function of growing season conditions at each site. So site 1, which was the more clay site, received more consistent rainfall throughout the growing season, which contributed to increased plant height in general. And we did see that across varieties, there were no significant differences in plant heights at any of the locations. So for the yield results, I'm just showing the yield results from site 1 and 2.